Abel's formula. In this video, we are going to learn what is the Abel's formula for the second order differential equation. Basically, Abel's formula is the mathematical formula that expresses the Wronskian of two solutions of the second order differential equation. So in this case, we have taken the second order differential equation of this form where a0, a1, a2 all are a continuous function and a naught x is not is equal to 0 means the coefficient of second order derivative is not is equal to 0. Moreover, we have two solutions for this differential equation. Let it be a y1 and y2 are the linear independent solution. In this case, these solution definitely satisfies this differential equation in terms of the Wronskians. Moreover, if the solutions are not given to you, we can directly find the Wronskian with the help of this differential equation that is calculated as constant multiple of e raised to power minus integration of a1 upon a0 with respect to x. Now a1 is basically in this case as the coefficient of y prime and a naught is the coefficient of second order derivative of y. Let's explore how to calculate the Wronskian without evaluating the solution from the differential equation using examples. So here we have a 4 example. We need to find the Wronskian of these differential equations without evaluating the solution. So first we need to observe whether all the coefficients of the dependent and its derivative are continuous or not. So in this case, the coefficients are constant. Even in the second case, the coefficients are constant. Whereas in the C and D part, coefficients are constant and constants are always continuous. Means we can directly use the Abel's formula to find the Wronskian. So for Wronskian, we need the value of A1 and A0. So A1 is the coefficient of second order derivative. What is the coefficient in this case? That is the 1. And A1 is the coefficient of first order derivative, that is equal to minus 4. So now directly apply the formula. So Wronskian is equal to constant multiple of e raised to power minus integration of a1 divided by a0. That is the minus 4 divided by 1. Take the integration with respect to x. So this is equal to constant times of e raised to power minus minus will be plus integration of a constant as x. So we have in this case 4 into x. In first case, we have the value of Wronskian as it is a multiple of e raised to power 4x. Now for the case number 2, so y double dash minus y dash is equal to 0. What is the coefficient of a1? That is the coefficient of the first order derivative minus 1. a0, that is the coefficient of second order derivative, that is equal to 1. So Wronskian in this case is equal to c as a constant e raised to power minus a1 divided by a0, that is minus 1 upon 1 dx. So this is equal to c e raised to power minus minus is plus integration of 1 is x. So in this case, the Wronskian is equal to the multiple of e raised to power x. Now what about the c part? In the c part, the value of a0, that is the coefficient of second order derivative 1, a1, that is the coefficient of first order derivative. Now the coefficient of first order derivative in this case is 0. So now we will find the Wronskian is equal to constant multiple of e raised to power minus the value of a1 is 0 divided by 1. So this is equal to constant multiple of e raised to power. So integration of 0 is 0. So e raised to power 0 is 1. So in this case, we will get the Wronskian as the constant term. For the d part, the value of a0 is 4, a1 is 1 and the Wronskian is equal to constant multiple of e raised to power minus. So that is the 1 by 4 dx is equal to c e raised to power minus 1 by 4 into x. So let's take another example. In this case, we have given that two solutions are there, y1 and y2. They are linearly independent solution of this differential equation. And it is given that the first solution at x is equal to 0 is 1. The second solution at x is equal to 0, the value is minus 1. Then if you take its derivative of first solution with respect to x and put x is equal to 0, in that case you will get 1. Second solution derivative when you take and put x is equal to 0, again we are getting a value 1. Now the question is, what is the value of Wronskian at 2? Since we don't know what is the Wronskian in this case, even we don't know what is the value of y1 and y2, exact value of this one, but we know their particular values at particular point, that is x is equal to 0. So whenever we have such type of a question, what you need to do, so we will use the Abel's formula first. So by using the Abel's formula, you can directly evaluate the type of a Wronskian from the given differential equation. So from this one, we have the Wronskian value as constant multiple of e raised to power minus. So the value of a naught in this case is minus 2x square divided by coefficient of second order derivative, that is the x. Take its integration with respect to x. So this is equal to constant times of minus minus will be plus integration of 2x dx. So this is equal to constant times of integration of 2x's. So integration of x, that is the x square by 2. So if you multiply by 2, so what you will get? X square. So here we are getting e raised to power x square. So this is what we are getting from the Abel's formula, the expression of Wronskian directly from the differential equation. Now you can use the original definition of a Wronskian. So Wronskian of the two solutions y1 and y2. This is calculated as y1, y2, y1 prime, y2 prime. That is the first order derivative of both the solutions. So we need to calculate this one. But according to the question, it is given that their values at 0. So we will write Wronskian value at x is equal to 0. So this means we need y1 at 0, y2 at 0, y1 dash at 0, y2 dash at 0. This means the derivative, first order derivative, that is equal to. So y1 at 0 is 1, y2 at 0 is minus 1. First order derivative of y1 at x is equal to 0 is 1. First order derivative of y2 at x is equal to 0 is again 1. So take its determinant. So determinant is equal to 1 minus minus of 1, that is equal to 2. From here we can say that Wronskian of 0 is equal to 2. But we need to find the value at x is equal to 2. Now use this result. So according to this result, Wronskian is equal to constant multiple of e raised to power x square. So if I put x is equal to 0 in this case, so it says that c e raised to power 0, that is equal to the constant c. It says that the Wronskian value at 0 is 2, and in this case the Wronskian at 0 is equal to some constant. So from here we can say that the value of constant is equal to 2. So if the value of constant is 2, what is the Wronskian in this case? So in this case, the Wronskian exact value is 2 times of e raised to power x square. Now, according to the question, we need the value of W2, that is means the Wronskian at x is equal to 2. So put x is equal to 2 in order to evaluate Wronskian at 2, that is equal to twice of e raised to power 4. So this is how we are using the Abel's formula in order to find the particular value of Wronskian at particular point.